Okay, continuing from previous video. So we made the blast alpha file combining the actual blast alpha file with the our subject file or plant promoter database, right? So we have this information. So this is from our accession query accession data, which is coming from Robot Region, and this is subject accession data, which is the headers of the printer promoter database, and we have other very important, very useful information of it. But as you know, already know that each gene, the upstream of gene, have um, many blocks of how is that promoter sequences. I mean, the binding sequences, I would say. So these sequences as well conserved. Actually, I need to add the organism also. Let me add organism here. Okay. What was that? OS, right? OS. 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 What is actually OS means? I don't know. So then you can see, okay, this sequence is well conserved with the GMIs, which is maize, right? Maize. So among these two sequences, well conserved, right? So, which means these sequence should be conserved with regard to certain function, certain role of this sequence block. Maybe this sequence block is required to attract certain protein or transcription factor or the other trans element, is that right? So we want to list up what kind of these elements are reside in the upstream of this gene. You can already see these gene. Maybe I will add more, 20. So it has a lot of sequences, 50. Right? So these 9960 have a lot of promoter sequences. So we will list up with regard to this one. Okay, so how can it be done? How can it be done? How can it be done? So I will list up then this hit sequence of query versus this name. Okay, so this is not that difficult. So query accession like this and hit sequence query like this. Okay. Okay. Then the query sequence. Let me change the scheme. This would be more easier, I would say. So for index, let's index it first. Data frame, curated, index, curated, set index, query, ACC bar, right? Then Okay, we can list up with regard to the indexes unique. Oh, so we have a unique query sequences shape. How many? So 5,000, 50,000 unique query sequence for each index. Each index, each data frame will be no index, right? So we can build dictionary index. No, index would have let's build it again. So what was that? Query ID, query ID and hit sequence query. Then I will add query ID append index dictionary hit sequence query and check header hit sequence query what? Okay, this will be many things, so I will join it with this one. It takes time. I'm thinking that I should add here values. No, string object has no attribute values. Okay, so sometimes it has only one. So accept what was the attribute error? Attribute error. I don't know why it doesn't change the color. Okay, so it doesn't have a value at all, then I don't need join it. I need to join it. Let's wait it. Sometimes it takes too much time and we don't know how much time it will take. Then you can export dqdm, import dqdm. Right? Okay. Then you can put here dqdm dot dqdm. Right? So you can see How long does it take? Oh, so this is problem. This is problem because it takes almost 30 minutes. So it takes too much time. Let me think, how can I reduce the time? I think the time is too much on this searching the index. So I will change the code. Okay. Let's comment out. Okay. And so the query ID will be actually index no actually I will use just everything. Let me check. I don't know if this work or not. In last curated index. No, maybe just curated and just apply a function data parse and axis will be 1 and definition a parse x will be I don't know if really fast or not, like get it fast or not. Let me try. Query ID. Dictionary query ID of n x. Query exception version, right? Query exception version. No. I will keep it in key rather IU. So this will be key and append what was that hit? Sequence query, right? So try except key error dictionary usually I will not do this to make it fast, because I have if it takes 30 minutes, then I will go to some company store, grab some coffee and come back, then it is done. So I will do it that way. But in this case, I want to show you how to get it fast than 30-minute things. Okay, let's run it. This is also iteration, but I hope it takes less time than before. Yep. So I have dictionary. Oh my, no. I have the information in this way. So I have the gene name of laboratory here, and the sequence block and the upstream of this gene is listing like this. So maybe I can transform this information in pandas. Use just data frame. How can it be? It doesn't show any result. Tick why. All array must all be same length. Then I will update the dictionary as we made before. So update. Query ID. So as you can see here, if you code not effective way, then it takes a lot of time. If you code more efficient way, then it will do it in just few seconds. Query ID, what was that? Hit sequence query. And for key in the dictionary, tick update and query ID, append key date hit sequence query, right? And the key. But I don't want to have it in list manner, so I will join it like this. What? No? Append. Good. And I will change this into data. Good. So everything is well parsed. So I will I will change the data frame name laboratory promoter block, maybe table. Good. So this is how you are building your own table for, what was that? The laboratory upstream, right? Laboratory upstream. So you have already genome of laboratory, and you are interested in rubber tree upstream to retrieve the promoter sequences, but you don't have any information of the promoter in rubber tree genome annotation, but you can extract the upstream sequence of rubber tree genes, and you can compare this sequence with existing promoter database, plant promoter database from software, and you blast between these two sequences, and using blast n rather than mega blast, and you allow even a high e-value, because e-value doesn't mean anything if you are interested in this small sequence block alignment. So you can parse the output of blast in this way. So sometimes this is very tricky because you don't have any database available for the rubber tree, but you can build your own database. And this is sometimes very useful for just looking at the possible binding point of your genes. And if you are interested in upstream promoter engineering, then I recommend you just do something on these sequences, right? And you already have this starting point and end point. You can visualize, I would say. Okay, so maybe maybe we can add or some visualization for this situation. Is all right? Maybe. And I want to add something here because there is some redundancy, right? I can see there is some redundancy. So I will update a bit. Can you see the redundancy here? Because the 55 to 79, 55, 79, but the heat is coming from different source, right? Different source. So maybe coming from different source gives you more weight, competence weight, than having the other thing, but having only one thing. But still, this is redundancy. So I want to remove this redundancy. How can you do it? So let me do it in this way. Q start and Q end is kind of indicative indicative of, let's use this one. So you want add query access dot bar and query start and query end. This is what we only use for parsing query. No. Let me check. Okay. Q start, Q end. Let me copy it. Okay. Okay. Then you can directly see these two is redundancy, right? So let's check the shape. So the shape of this data frame is like this. Let me remove drop duplicate and shape, and it become less number than this, right? So this is really important. Then I will change remove redundancy. I mean remove. redundancy. Right? So then let me use this one to have our dictionary. Let me run it again. Good. promoter4 and pro. What time is it? I will do it more, 5 more minutes. Okay, so run and update. So now you have this list. Maybe you add blank here, and this is more readable than before. Is that right? Okay. So you can export to CSV file and rubber tree from motor mining table CSV parse. Right? Let's check this file. So if you go to where is my here I plant this one. You made very big table showing the upstream blocks of the gene. Very interestingly, so with your bare eye, these genes sharing the data box. Interesting. These genes sharing almost identical set of blocks. Interesting. This is also, right? This is also. And so maybe we can do it more with regard to how these are shared. This is so interesting, right? This is really interesting. Exactly shared. Maybe it is kind of duplicate of same gene, maybe. And these are also. So from this, maybe you can design your own primers or own construct, extracting sequences from it. So maybe you are already recognize you can utilize these bios and you can extract the planking sequences. So maybe if you are interested in this sequence, maybe you are required to have the upstream of this sequence and downstream of this sequence, right? So I would say you can utilize this bio to extract this one and this one, the downstream sequence and upstream sequence and downstream sequence, right? So that's it. If you're interested in the other topic of mining the genome sequence, please give me a question Okay, so I'm thinking that I will teach you how to visualize, next time I will teach you how to visualize um, these upstream promoter sequences. For example, um, we are having this information, right? Then we can visualize matplotlib pyplot. So this is the module that we are using when we are, I say, when we draw the plot like this, and this is x-axis and this is y-axis. Okay, so your 53 and 68 you have, right? You have, and your y by u will be just 3 and 3, and it gives you this line. And you have another sequence plot, is not sequence, the by u, this 5, 79, and you will your how you say 4.4, right? And your another compound will be plot and 35 and 49 and 0.5, and you can, I say, visualize everything in one let's say panel, in one panel, is right? So what time is it? Do I have time? So I will use another 3 minutes. I will use set index query x bar no equal has, and we will have this one. You will know that this one have a lot of sequences, upstream sequences, right? And you can use this set index. You can use this by you, and for index in this index, no, data frame stop, easy naming, data frame solve, and data frame solve location will be each data frame. So each one would not be data frame, but I will use data frame. Start and for end to be our set x and y index and index. Okay, x comma y, right? So this is how we can visualize. This is how we can visualize the promoter sequences in the upstream of gene. So this is preliminary code that I'm visualizing this upstream promoters. So next time I will explain you more exactly. Thank you. See you next time.